Good morning, everyone. I am Nitya Tyagi, and this is my presentation on the topic torque transducer. So, let's begin with the definition of a torque transducer. So, what is a torque transducer? A torque transducer is a type of sensor that is used to measure the torque or any rotational force applied to a shaft or any of its components. So the basic principle on which a torque transducer works is basically it measures the amount of twist or deformation that occurs in a shaft or its component when torque is applied. The twist is then converted into an electrical signal that can be measured and analyzed. There are multiple types of torque transducer. This might include strain gauge torque transducer, an optical torque transducer, magnetic torque transducer, a piezoelectric torque transducer, or a capacitive torque transducer. So there are many advantages to a torque transducer. This may include accurate measurement. A torque transducer provides accurate measurement of torque with a high degree of precision. Real-time data. A torque transducer can provide real-time data which can be useful in application where real-time monitoring is an important factor. Or next is non-contact measurement, which could also be a very useful factor. So, like non-contact measurement techniques such as optical or magnetic sensing, which do not require physical contact with the object and us. It is easy to install, which is a great thing. So why do we need a torque transducer? So a torque transducer are used in wide range of industrial, automotive, and scientific application to measure torque accurately and precisely. Here are some of the reasons why you may need a torque transducer in your situation, uh, such as if there are factors like quality control, research and development, maintenance, or calibration, you might need a torque transducer. So, along with all of this, there are many characteristics to a torque transducer. I have discussed a few here. Let's begin with the linearity of a torque transducer. So, the linearity of a torque transducer refers to its ability to produce a linear response to an applied torque. In other words, a linear torque transducer will provide an output signal that is directly proportional to its applied torque. Linearity is an important characteristic to consider while studying characteristics of any instrument, here torque transducer, as it affects the accuracy and reliability of torque measurement. In this case, a highly linear torque transducer will provide more accurate measurement across its entire range of operation, whereas a non-linear torque transducer might not do this. We can counter this by calibrating our torque transducer to some extent. Next is sensitivity of a torque transducer. So the sensitivity of a torque transducer refers to its ability to accurately and precisely measure small changes in torque. It is typically defined as the ratio of change in output signal to the change in torque. The higher the sensitivity of a torque transducer, the more accurately and precisely the torque measurement it can make. Next is hysteresis, which is another important factor to consider. So, in a torque transducer, hysteresis refers to the difference in torque reading and obtained when the same torque is applied to the transducer, depending on whether the torque is being increased or decreased. This occurs because the mechanical component of a torque transducer exhibit a degree of elastic deformation when subjected to a torque load. It is important to account for hysteresis when using a torque transducer for measurement applications, as it can result in inaccurate or not proper readings. Next is temperature stability. As there are many components in a torque transducer which might be sensitive to temperature, this is an important factor to consider. The temperature stability of a torque transducer refers to the ability of the transducer to maintain its accuracy and performance under varying temperature conditions. Torque transducer typically operate using strain gauge or other types of sensors that are affected by change in temperature. So it is important to ensure that the transducer can provide accurate measurement even when the temperature changes. Overall, the temperature stability of a torque transducer is an important consideration when selecting and using the transducer for precision measurements. Repeatability. The repeatability of a torque transducer refers to its ability to consistently and accurately measure the same torque value when the same torque is applied multiple times. The repeatability of a torque transducer can be affected by the variety of factors, including its design, construction, and calibration. A high quality torque transducer with a robust and precise design, made from high quality material and calibrated regularly, can achieve a very high repeatability. So there are some drawbacks to a torque transducer. Some of the physical drawbacks to a torque transducer include size and weight. Torque transducer can be relatively large and heavy, which might be a problem transporting them, installing them, and other factors. Sensitivity to variation. Torque transducer can be sensitive to variations, which can affect the accuracy of the readings, which might be a good and a bad thing, as it is sensitive to small torques, which could result in bad readings, but in some case might be a good thing where you need to measure a smaller amount of torque. Susceptibility to damage. Torque transducer can be susceptible to damage from impact or overloading. So, okay. Thank you very much.